The converse of the Pythagorean theorem. So a converse means that we are going to flip-flop the statements of Pythagorean theorem. The statements of Pythagorean theorem, it first stated, if we have a right triangle, then a squared plus b squared equals c squared. So in rearranging that, we're now going to say, well, what happens if we say if a squared plus b squared equals c squared, then the triangle is a right triangle. And in fact, this holds up. This does not happen every day that we can take a statement and rearrange it and get another theorem or another rule that holds up. For example, we could say, if it is raining outside, then it is wet. And for the most part, that's correct. The sidewalk or the pathways would be wet. But if we flip-flop that and we said, if the sidewalks are wet, then it is raining, that's false because the sprinklers could be on. Somebody could have dumped some water on the ground. And so this only happens at certain times. And so essentially, this is the part 2 of Pythagorean theorem. We're saying if we have some random triangle, this is not to scale, that is let's say a 5, 12, 13, and we plug these values into Pythagorean theorem carefully. So we can't randomly place these because we know that C is the hypotenuse. And if this is potentially going to be a right triangle, then this needs to be the C value. So the longest side needs to be C. Otherwise, I'm going to get false or wrong answers or things that aren't right triangles that actually are. So let's see, is 5 squared plus 12 squared 13 squared? So if I have these sides and it tests out in Pythagorean theorem, then I can actually say, I can make a more accurate sketch and say that this is a right triangle. This angle is a 90-degree angle. And in fact, in using the converse of Pythagorean theorem, if I plug numbers in and I end up getting something that fails, and you can Google this, it's not really embedded in the lesson, but if it's not a right triangle, then what type of triangle is it? Well, the other types of triangle classification based on angles are acute and obtuse. So there's actually a way to determine without a picture and without a protractor, just based on side lengths, using this converse, whether it's right, acute, or obtuse. So that's the converse of the Pythagorean theorem. If we take the side lengths, plug it into Pythagorean theorem, and it works, then we can determine that it is a right triangle.